Namaskar, this is Professional Eng Suraj Singh. I am continuing my sequence on civil engineering building practice. I was telling you something about these buildings. Now I am going to continue on that, commencing with a complex, with a campus layout and detail about further buildings. I will look on this place. This is a small complex for any educational institution. Various buildings are shown in this. This is the layout plan of a college campus actually. You will see this portion here. There are certain buildings shown as B1, B2, B3, etc. This is B7, this is B1, this is B2, this is B9, this is B4, B5, B6, etc. And there are surrounding buildings here. Boys hostel, this is tennis, this is swimming pool, this is tennis, this is girls hostel, this is staff dwelling unit, this is park, this is building A, building B, building C, building D, E, F, G, this is park, etc. This is park, this is girls hostel. This is a typical unit of a complex because it's a small university, you can say. Now, I'll detail about these buildings here in the core area. These are B7, B1, B2, B9, B4, BF, and B5 and B6. And there is a further layout of this for this complex. The size is about 175 meter by. This is 175 meters here. Plot area is 3.5875 hectares. It's quite big in consideration. And it is 14 number into 5 meters is 205 meters. So the plot area here it is 175 meters by 205 meters, which is 35,875 square meters, 3.5875 hectares. In this core portion, let us see, this is the layout of the core portion. As I said, this one building, two building, third building, fourth, fifth, sixth, seventh, and in between pergola and this open courtyard. And if you see, this is the compound wall here. This is the compound wall. This all is compound wall. I have shown various grids at 5 meters spacing, and compound wall height is 1.2 to 1.5 meters. This timber profile has been actually, I have done a timber profile on this for the purpose of control of these grids. Here you see, this is the main entry. There are some pergolas, and you can circulate like this. You can circulate like this. A to P, A, B, C, D, etc. And this side is 1 to 17 grids. And this is the grid plan of setting for the setting out purpose. And this is in the portion of the timber profile out of grids to be removed. This is for the temporary purpose actually now for the time being, but it could be a compound wall as well. Now let's go to ground floor layout of this building. In the ground floor layout, this is the ground floor layout. Now what is the purposes? There are so many buildings for this area, for this ground, and all these buildings have been grouped together. If you see, when you enter here, there would be assembly hall here, and when you go this way, it's a workshop. Then there are toilet areas. Then there are rooms for the classrooms, etc. Here, these are all rooms. These are rooms, and these are 2 laboratories. This is lecture room, library, etc. Library. This is courtyard, and here are other rooms. You can see lecture rooms and many other types of rooms. There are, you can see how many classrooms? 4 classrooms here, 2 classrooms, 6, 6, 4, 10. 10 classrooms here, 240, 2 labs here, 2 rooms here, 2 rooms here. So there are 16 classrooms, 2 laboratories, 1 workshop. This is on the ground floor. So there are planters and so many other items are there. Let us go to the next one for this. That is next floor. This is first floor layout of the same. This is the first floor layout. In the first floor, further details are given. There are rooms here, rooms. These are rooms. These are rooms. These are rooms. There are rooms here, first aid here, and there are dark room and laboratories. And this is a portion assembly cut because assembly is double height. Double height, you can say it is meeting at the roof. And this is plant room area. This is the internal pergola. This is first floor. These are the circulation areas. This is covered and this is open. If you go to the upper one, this is roof layout. It is simple, not very difficult, but it is easy to understand. You can see smaller. This is assembly hall. This is a workshop roof, lower level. This is a classroom roof, and this is a terrace on the top. This is a plant room here. This is a plant room here. Plant room here. This is the design of this building. It is actually part of the campus. If you see the sections now, you can see the foundation. Here is the foundation. Foundation is RCC footing. This is typical actually. RCC footing and waterproofing there. That is called protection. This is black color. Protection of concrete for the concrete, and there is a block work here for protecting the protection. You can see here also same block work for protection of the concrete, protection of the membrane. And this was bitumen actually, protection membrane. And for the ground floor, grade slab, you see the RCC here, and flooring on the top of that, and a blinding membrane below, and top of that is polythene sheet. Similarly, blinding here, and blinding. And if you see the typical section, this is the section of assembly hall area. You can see the foundations. This is the assembly hall. This is the hall, and this is the corridor up in front of that. See the height double, and there is a ceiling here, roof here, and roof here. These are the fascias. There are fascias on both sides, here and here, and there are planters. This is the floor, rubber floor here. This is shown in black because of the continuation. This is the typical section for this assembly hall. This roofing, you see, this is a standard roofing system, upside down, which is valid for 10 years warranty. This is a graded roof actually, 1.25% graded green for the purpose of rainwater disposal. And we'll see the next one now. This is another section. This is also for the corridors and workshop, corridor workshop. Simple section it is. You see different types of window arrangements, window sills and on the rooftop. You see here also the same. This is for the corridor and electrical room area and changing room, etc. On the first floor is plant room, pump area, terrace. All these give the sectional details for that building. It's not very complicated, but just given for the purpose of understanding, purpose of knowing about the requirement. This is now classrooms area. So this is classrooms area. This is classroom on the ground floor, classroom on the first floor, corridor on the ground and first, and stairs continuing up to the second floor, to the plant room, on the rooftop and plant. You see on terrace is a plant room, one side terrace and other side is plant room where HVAC units were kept. This is the terrace, and if you see a detail of suspended floor, that's called access floor. Also, it's called it's used generally for the IT rooms, for computer rooms. And there is suspension wires here. And if it's ceiling tiles, this is the tiles here. And also suspended ceiling it is. The same type of details. This is suspended ceiling actually. I did not incorporate this false floors, but it is done in computer rooms. There is ceiling also again. And if you see more details here, this is section 5.5, which is for classrooms, So both sides are classrooms, and say classrooms, library on one side, classroom on the other side. This is the roof. This is classrooms and corridor and lab. Classrooms again, false ceiling below and labs, corridor, library, curtain wall, extended protection, roof fascia, parapet, floor window sills, similar type of details, floors, and this is typical roofing details which I was spelling upside down. Here is a fascia in the like in the parapet. You see this is clear, and this is the roofing system. This is the roofing system. It is also showing aluminium flashing on the skirting, roof skirting, suspended slab, and the space which is here for the parapet is to be used for MCC, etc. and HCC actually. It is another detail for roof skirting. Here are roof tiles and extruded polystyrene. Below that is roof tiles, and below that is cement mortar. Nowadays it is not used. Cement mortar is not used, but foam concrete is used. This is the details of roof, which is considerably good. We'll go to the next one. This is another project, and that is firing range, or we call it shooting range. Shooting range, it was 300 meters long. 300 meters long. This is the main building of the shooting range. Administration building or control building, or you could say. This is the office here, and shooting places here, shooting area, and this is all shooting area here, pistol area and shooting area. This is, if you go like this, you are in the range, you are going in the range. This is the range, you are going in the range now. This was the graded ground, 0.5%, and this is in continuation, is coming from here. This is target pit 1. Then again it is going graded and going, and you are going target pit number 2, and further it is moving from here. Target pit number 3 is moving on further to other side, and this is bullet trap chamber here. Bullet trap chamber, target pit number 3. So this is all from top of you see. This is the office here, shooting portion. This is going this way, then going this way, and then going this way. This is the direction. This is bullet trap chamber, and here there are corbels. You know, gantry. What do you call this? Baffle walls. Baffle walls are placed here in between the target pits. Baffle walls are provided. I'll show you in the section how it was done. You see here, this is the shooting point here. It's going to, from here to, it is in longitudinal section. I'm just reflecting. This is going to 100 meters, then going further to 100 meters, and then going further to 100 meters, and there is a bullet trap chamber. These 3 are tunnels, actually point 1, point 2, pit 3, pit 1, pit 2, pit 1, pit 2, pit 3 are underground tunnels. These longitudinal sections, and you can see this is a detail of pit. This is the target pit. This is the target pit here. This is the underground way. Step down. This is like a tunnel, cross tunnel, and here is the bullet trap chamber. You see the RCC slab, long slab, resting on a column, and sandfill is here, compacted earth and then sandfill, and this is also a pit here connected with that. If you see this one, this is the target pit detail. This is the target pit. This is the pit. Pit showing the details, how it works, and also here another one. And I was just telling you that there were baffle walls provided. This is the baffle wall now. I'll show you baffle wall. This is the baffle wall. This is the gantry girder. This is the gantry girder here, and this is the main wall, shooting range. This is the 300 meters long wall. This is the baffle wall. Armored plate is provided on this gantry girder, and these are the corbels. These are the corbels. The height of this gantry girder is 1.5 meter, 2.5 meter, and 2.8 meters. And width is 25 meters. This is baffle wall here, and this is baffle wall here, 300 meters long, and these are gantry girders. This is the shooting range, and next vision is, I'll show you the details of armored plate now. This is the armored plate. You can see this section. This is boiling water proof. This is BWP, boiling waterproof. This is the plate cladding. This is called ply cladding, 40 mm thick. This cladding is 40 mm thick, and this is 20 mm thick armored plate. And this is connectors are here. This is hung on this girder. This armored plate working details, steel gantry. And now we go to other sections of this. This is pistol storage, pistol keeping area. You see epoxy floor is there. This is the rack for the pistols. Very important arrangement. And similarly, you see this is section through the office. Section through the office where we have this entrance, then corridor, and then shooting hall. And there's some other details here. This is regarding the shooting range. Once again, let me give you a review. It's a very important project. This is the office, and we are moving on the shooting range now. Like this, then like this, and then like this. This 300 meters range with different details. Here. Then next one, further details of gantry, baffle walls, and other storage. Now I am going to another project, that is diesel power station, standby. This was in SPLHA Libya. This is the power station. You can see 4 locations of standby generators, very big generators, very heavy generators. And this is the control room, electric room you can say. And this is the periphery of the control area of the substation and power station. This is diesel power station. This is 4.2.5 kV diesel power station. This was standby for that area. And if you see, there are fuel oil tanks here, 2 fuel oil tanks of very big size, steel construction with raft foundations. And here is another radiator. This is a radiator. There's a radiator. And here is overhead tank, fuel oil tank. And this is switch gear area, transformer area, switch gear. This is the elevation of fuel oil tank, RCC base, steel vertical cylindrical shell. This is the radiator. This is fuel tank, pump, and this is section through the building of substations. These are the generators. This is the office area, and it is the overhead crane here inside. You can see this truss. This is about this power generation system. and we'll see further the generator formulations, how it works. You can see the generator formulations, very important arrangement. This is actually a machine foundation. You can see here, this is alternator. This is the alternator foundation. There is a raft below, big raft, and this is generator foundation here. This is generator foundation, quite deep, 1.95 meters. Machine foundation this is, and this is 3 meters deep alternator foundation. And there is a big detail about isolation. In between the alternator foundation and generator foundation, there is a cable trench. This cable trench is very big, and I'll show you further details of base. This is the base, RCC base on the blinding. And there is isolation system in between the two, and these are grooves for the bolts, anchor bolts. And this is isolation system. Polystyrene, this is polystyrene, neoprene, this is neoprene, and this is also neoprene, and this is the section, this is the section here, detail section. You can see a lamina, MS lamina, sitting on the isolation system. What lamina it is? It's here, the lamina. It's MS frame actually. It's MS frame. You can see the frame here. This is the frame. It shall rest on neoprene pads. It shall rest on neoprene pads. These are the pads here. This is the pad, for example. This is the pad, for example. The whole system is like this. So we say MS lamina is this MS lamina, then PVC 1000 gauge sheet, the neoprene sheet, then heavy duty polystyrene 32 mm, and 8 mm thick MS plates on which are the pads. And this is the footing details of these columns, structural steel columns. This is also the big foundation for the generator. So this is all, and you can set as electrically operated overhead crane, which is resting. You can say this is resting here. Crab crane, quite heavy. This big girders, and this is fuel oil tank foundation. There is a retaining wall here, and there is a retaining wall there. Foundation, and this is the tank portion, and this is also various details. This is for this diesel station. There are many other details, but these are the major details that we had to study a lot. Since it was in Libya, materials were not easily available. Once again, have a look on this. This is for the spanning. This is another building now I am showing, which is a threshold and a swastik, the combination of the two. This is also a building, very good building. This is about, you can see, it's a long building. This swastik, this is threshold, Bharat culture threshold. This is the threshold. You can see this. I'm going to take this slowly so that you can see it very well. This threshold is very complicated in design, but this is very good architecturally. It reflects Bharat Sanskriti, Bharat culture, and it's like you see this is moving on continuously. I'm moving it further so that on the terrace I have taken many machines. If you see this complex is about 305 meters this way, 305 meters by 170 meters. 305 meters by 170 meters. This is 7,850 square meters, and covered area is 7,575,904. FAR is 146%. Coverage is 18%. Ground coverage. 400 number car parkings. And this is an ancillary building here. That is standby. You can say it is a miscellaneous type of building, and this is a swastik shape, as I showed you before. This is smaller than that, but very important. It's only 35 meters and 35 meters this way. It's 35 the length of swastik here. It's very important from combination of the two shapes, the shoe and swastik or swastik complex. They call it over a tank and substation. Once again, I'll try to reflect on the swastik. On Trishul, which is very important because it is very complicated design. On the its aerial view, isometric or aerial view, you can say it's aerial view. This is moving on this. You may like it. Many stories are there, and this is now car parks. This is car park and pergola. This is road, car parking here. This is guardhouse type. All parking lot, you may say. Parking lot and lawn, a typical complex structure. I would like to take it to the other one. A typical building here. You see, the typical building here, another type. You can say T have been joined together. Just this reflection, no details available. It's another drawing, big complex, but I just reflected in here. And it's a rough design. Now it's another design, which is a book cover complex, which is put on the cover of the book. This is now in black and white line work. You can see this building, one of the buildings. You can see another building, central one, which is a tower-like structure. You see the third one, which is a box-like structure. This is a box-like structure, and then Y-shaped structure, and then another Z-shaped structure. This is 36,392 square meter plot and 48,565 square meter of coverage, 132% FAR. Car park 5 at 17 numbers. Ground coverage 13%. These are the highlights, features of this commercial center. This is little tedious, but see the parking lot. This is the parking lot. This is the parking lot. And I will give you another view of this again, because it is, you may not be able to see this is uncolored. So I focus on the central building size. It looks nice. Moving over, scanning over this, because it gives a view of the. Well, take it to the other one. Well, it's a different one. Let me see again, because next one is time consuming, so I'm just trying to focus you on this itself. The purpose is the purpose is that we must do something which is good for the engineering purpose, and it's not that easy. Buildings, a big complex, and designs of the complex, controlling various parameters. No complex can be designed without the correct inclusions, correct foundations of the regulations and bylaws. Bylaws are varying for every municipality, every city. We have to comply with those regulations, producing the complex or integrated complexes. All these buildings which I have been reflecting are integrated complexes which are self-contained for all the facilities. This is very necessary as National Building Code of 2005 has also permitted the production of or work on integrated planning, it is called, because we are integrating various buildings in one plot. Each building is not separate. There is a major plot in hectares, and main building is there, many other buildings are there, roads are there, all facilities are there, ancillary buildings are there, substations, parking lots, guard houses, plant rooms, and for residential complex there will be many more, for example market or nursing home. And this is what is the requirement of a good complex. Swimming pools are also there, but it depends upon which project it is. In this book there are so many others which I will reflect you in the next video, as these buildings I have given you are based on certain considerations which are good for our nation, and I'll show you certain details of how the steel looks when placed on site in the next video, and how many other details are there. Swimming pool I will show particular details of swimming pool, which is also important from engineering consideration, site consideration, and design consideration. All these are very, very important.